Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem-solving skill in mathematics. First, we will analyze the problem on hand to find the related concepts. Then, using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in mathematics. In this video tutorial, we will discuss two more multiple choice questions with only one correct option on the rate of change of quantities by the method of differentiation. The questions are as follows. We have numbered the questions in continuation from the previous video. Question 3. A balloon always remains spherical on inflation. It is being inflated by pumping 900 cubic centimeters of gas per second. Then find the rate at which the surface area of the balloon increases when its radius is 15 centimeters. The options are 120 centimeters square per second, 100 centimeters square per second, 90 centimeters square per second, and 60 centimeters square per second. Question 4. The size of a rectangle is changing in such a way that its length x is decreasing at the rate of 5 centimeters per second and its breadth y is increasing at the rate of 4 centimeters per second. Then find the rate of change of area of the rectangle when x is equal to 80 centimeters and y is equal to 60 centimeters. The options are 9 centimeters square per second, 15 centimeters square per second, 20 centimeters square per second, and 24 centimeters square per second. The related concepts are already discussed in the previous video application of derivative 1. Hence, we will directly go for the solution. First, let us solve the problem in question 3. Consider a balloon of radius r, volume v, and surface area S as shown in the figure. It is given that gas is pumped into the balloon at the rate of 900 cubic centimeters per second. Therefore, the volume of the balloon is increasing at that rate. Therefore, we write dV by dt is equal to 900 cm cube per second. We are required to find the rate of change of surface area ds by dt when the radius of the balloon is r is equal to 15 centimeters. Now, to solve the problem, let us establish a relation between the quantities involved in the question as follows. Now, the volume of a sphere of radius r is given by v is equal to 4 by 3 pi r cube and its surface area is given by s is equal to 4 pi r square. In the first step, we differentiate the volume with respect to time using the chain rule of differentiation, which gives dV by dt is equal to dV by dr into dr by dt. Putting v is equal to 4 by 3 pi r cube, we get dV by dt is equal to d by dr of 4 by 3 pi r cube into dr by dt. Now, d by dr of 4 by 3 pi r cube is equal to 4 pi r square Therefore, we have dV by dt is equal to 4 pi r square into dr by dt. Putting dV by dt is equal to 900 cm cubed per second, we get 900 is equal to 4 pi r square into dr by dt. We are required to find the rate of change of surface area when r is equal to 15 centimeters. Therefore, in the second step, we put this value of r to get 900 is equal to 900 pi into dr by dt, which gives dr by dt is equal to 1 by pi centimeters per second. In the third step, we differentiate the surface area with respect to time using the chain rule, which gives ds by dt is equal to ds by dr into dr by dt. Putting s is equal to 4 pi r square, we get ds by dt is equal to d by dr of 4 pi r square into dr by dt. Now, d by dr of 4 pi r square is equal to 8 pi r. Therefore, we have ds by dt is equal to 8 pi r into dr by dt. Putting r is equal to 15 centimeters and dr by dt is equal to 1 by pi centimeters per second, we get ds by dt is equal to 120 centimeters square per second. Therefore, the correct option is A, which is the answer to question 3. Now, we solve the problem in question 4. Consider a rectangle as shown in the figure. The length of the rectangle is AB is equal to x and its breadth is AD is equal to y. It is given that length decreases at the rate of 5 centimeters per second and the breadth increases at the rate of 4 centimeters per second. Therefore, we write dx by dt is equal to minus 5 centimeters per second and dy by dt is equal to plus 4 centimeters per second. We are required to find the rate of change of area of the rectangle, which is dA by dt, when x is equal to 80 centimeters and y is equal to 60 centimeters. Now, to solve the problem, let us establish a relation between the quantities involved in the question as follows. In the first step, we have noted the expression for the area of a rectangle of length x and breadth y given by A is equal to x into y. In the second step, we have differentiated this equation using the product rule of differentiation, which gives dA by dt is equal to d by dt of x into y, which is equal to y into dx by dt plus x into dy by dt. In the third step, we put the values of x, y, dx by dt and dy by dt, which gives dA by dt is equal to plus 20 centimeters square per second. This means that area of the rectangle increases at the rate of 20 centimeters square per second. Therefore, the correct option is C, which is the answer to question 4. This completes the answer to the question.